One brain for all your agents. Auto-learning, cloud-backed shared brain for Claude Code, OpenClaw, Codex, Cursor, Hermes, and Pi. One engineer's agent solves a tricky migration on Monday, and by Tuesday every agent can execute that pattern. On a public long-context memory benchmark called Lacamo, hivemind is 25% cheaper, uses 1.7 times fewer tokens, and requires 31% fewer turns than running without shared memory. Hivemind is more than remember. It mines your team's traces for repeated patterns, turns them into reusable skills, and propagates those skills back into every agent in real time. The junior engineer's agent feels sharper because it inherits what the senior engineer's agent discovered the week before. It captures every session's prompts, tool calls, and responses as structured traces. It codifies patterns into skill files that every agent can use. It searches traces and skills with a hybrid lexical and semantic approach, falling back to a simple keyword retrieval if embeddings are off. It propagates new capability across sessions, teammates, and machines instantly. It intercepts file operations in a special virtual file system. It summarizes sessions into AI-generated wiki pages. You can keep all the data in your own cloud bucket, Google, Azure, S3, or on-prem, and the plugin is careful about privacy and security. Only a few lines of command line wizardry are required to get started. Install the global package and run a single install command, after which the installer detects every supported assistant on your machine, wires up the necessary hooks, and opens a browser for you to sign in. If you're running in a headless or continuous integration environment, you can give the installer an API token instead. For those who prefer a plugin marketplace, you can install through the Claude Code plugin interface, or for OpenClaw you use the ClawHub plugin system. Every other agent, Codex, Cursor, Hermes, and Pi, has a simple command that drops the appropriate hooks, installs a skill bundle, and then you just restart the assistant to see it in action. Once installed, you can check which assistants have been wired up with a status command. The output tells you whether capture and recall are enabled for each assistant. By default, auto capture and auto recall are on for every supported agent. If you want to instrument only a single assistant, you can pass an extra flag during install or run a dedicated install command for that tool. Hivemind plays nicely with a built-in memory plugin called MemoryCore. It does not take over that memory slot, so any built-in dreaming or other background jobs continue to run. It simply captures session data and adds its own commands. MemoryCore keeps owning recall, promotion, and dreaming. When the agent model is very large, such as Claude Haiku 45, the plugin can feel a bit slow because it makes many small tool calls per turn. Switching to a smaller model like Claude Haiku 45 episodes a lot of latency. Here is a quick start guide for a terminal user who has the global package installed but hasn't signed in yet. Open the browser and sign in with your account. After that, every assistant will automatically use shared memory and skills. The core workflow is straightforward: capture, codify, propagate, then compound. Each coding agent interaction creates a structured trace. A background worker mines these traces for repeating patterns, asks the model if they are worth keeping, and writes a skill file. Every hivemind connected agent loads those skills into its context at inference time. You can ask your agent naturally to search for traces or skills. What was MNULA working on? Search traces for authentication bugs we solved. What did we decide about the API design? Show me the skills my team has codified for handling migrations. The plugin will fetch relevant logs or skill files and present them. If you ever need to disable capture, you can set an environment variable so the agent runs in a read-only mode. For debugging, you can enable verbose hook logs with another variable. Every session, a background job produces an AI-written wiki summary and stores it in a special table. You can browse those summaries at a local path. The summarizer runs on the host agent's own command line, so you don't need a separate API key to get the summary. Skills are codified automatically. They live under a skills directory in your project, and a hidden directory stores shared skills across the organization. The plugin can pull and unpull skills from teammates, keeping everyone's local copy up to date. The graph feature builds a live graph of your code base from the same traces it captures. It tracks files, symbols, imports, and the edges your agents actually traverse during real sessions. This lets you ask the agent where do we handle off, and get the precise files the team has touched, instead of just a fuzzy text match. Rules and goals can be shared across agents as well. Each time a session starts, the agent receives a block of rules that describe your team's principles. These rules are injected in a way that makes sure no action violates them. The agent will surface a warning before proceeding. Goals and key performance indicators can be managed with simple commands that create or update markdown files under a virtual file system. On the architecture side, every agent has its own integration mechanism, plugin, hooks, skill injection, or native extension, but the core logic lives in a shared monorepo and publishes a single set of documentation. The Atlassian diagram in the repository shows how the core, the skill executor, and the capture hooks tie together. Hivemind runs against a deep lake backend. All traces and skills are stored in secure, tenant-isolated tables. The data travels over HTTPS and is encrypted at rest with AES 256. You can host the bucket in your own cloud storage, whether that's Google Cloud, Azure, Amazon S3, or a private S3-compatible bucket. The plugin will only see encrypted data, and no raw cloud keys ever leave the size of those buckets. With a plugin installed, you are ready to pass knowledge from one coder's brain to the next, grow a shared memory of the entire team's best practices, and reduce friction on repeated patterns. If you have questions or want to get involved, the community is open on Discord and Slack, and the codebase lives on GitHub, where contributions are welcome.